Hi everyone, welcome to MacMind.io. My name is Johnny Mac. I am a software professional and the host of this channel. Thank you for tuning in to check out this video. I'm really excited to share with you today about how to build an image for your Raspberry Pi that boots straight to a Chromium browser session without any console output. Be sure to watch all the way through to the end. There are a few considerations for this one that you're going to want to hear about. Specifically the matter of wireless network connectivity and how to set that up in a user-friendly way when the device is in kiosk mode. But before we do, I want to thank everyone that's been watching my videos so far. This is a new channel and I'm truly inspired by the engagement and feedback that I've been getting. It's so great to see folks out there getting value out of these videos. Please consider subscribing if you haven't, as I'll be making more Raspberry Pi tutorial videos, always using rpi-image-gen to produce a custom image. A few other disclaimers. I am using a Raspberry Pi Model 4B for these videos, and while it should work on a Pi 5, I don't have one to test with yet. I do have a plan to get a Pi 5 later this week down at Micro Center so I can help troubleshoot issues and ensure compatibility. I'm also building images on an M4 Mac with an Apple Silicon ARM64 processor. I've gotten some great feedback from you, and I know the process to build these images using Docker is slightly more complicated on a machine with an x86 processor. However, I do have an older Intel x86 Mac, and I've successfully built these images on that, so I do know that it's possible. Please reach out in the comments or open a ticket in GitHub if you need help. I'm eager to iron out these use cases and document the solutions for others to see. It's just my experience also after doing this for over 20 years that if you stick with it, then you can get through whatever challenges you're facing to get that result. Okay, so back to our project for today. Why would you just want to boot your device to a browser session? What's the use case for this? One of the more popular emerging use cases for the Raspberry Pi is the kiosk. And so if we see here some examples of a kiosk, we have here the pay station, right? This is an ever increasingly common thing to see when we go park. We have to pay and we go to the pay station. And this is actually off of a site that claims to run these kiosks with a Raspberry Pi. We also have the classic food stand kiosk where we go up and we order some food. And then of course there is, oh wait, look at that. It looks like St. Peter has now been replaced by a kiosk up there. So again, very common and popular new way to conduct business and transact with people. Instead of having to have a stand with people that are taking these transactions, we can now service these needs for people with a kiosk. And the Raspberry Pi is a great device for that because it's a simple computer. It can process and it can connect to outside services and it can do all that work, and it's a very affordable piece of hardware that's also very reliable. So this is an increasingly popular choice for a lot of product manufacturers to use when they are considering the hardware for these kiosks. And there are various ways to deploy an application for a kiosk. Some are more complex than others, but the simplest is just run a browser in full screen mode with OS and application features disabled to highly restrict what the user can do. When you're in this mode, you can load a web app, either served from an external service or just running locally on the device. And so long as the app is built as a kiosk app with like layout and controls and fonts appropriately designed, then the user doesn't really know that it's just a browser in the background. Now there are many tutorials out there on how to turn your Raspberry Pi into a kiosk. We have one here from Jeff Geerling. Jeff is a very popular Raspberry Pi enthusiast. He makes some awesome Raspberry Pi videos. And we see here he's explaining how to set up your Raspberry Pi and turn it into a kiosk. A lot of great insight here about, things like rotation of the screen and power savings, dimming the screen when it's not in use, that kind of stuff. Some great features here I actually didn't implement for this project, but maybe we could enhance our project in another video. He also references a website here, and I can tell you this website really drains my machine and slows it down a lot. This is from someone named Gus. This is a few years ago now even, but you can see he's talking about how to utilize Chromium and create a kiosk from your Raspberry Pi. And then We also have one here straight from the Raspberry Pi tutorials, and they're talking about how to use a Raspberry Pi in kiosk mode. So there's a lot of demand for the Raspberry Pi in this manner. And so I think that's part of why, we are exploring this, and how do we now build an image with rpi-image-gen to produce an image that's going to run the device in this way. And so again, these are great tutorials that we found, but they're all kind of using the same pattern, right? Where you install the RPI base image, boot it up, configure things, right? And we want to use rpi-image-gen to build a custom image so that we're just booting the device and it's already all set up for us. So that's what we're going to learn how to do today. So let's get into how to do it. We're really lucky on this one because our friend Matthew Lear, the lead maintainer of rpi-image-gen, has provided us with an image layout in the examples that does exactly what we're talking about here. So let's go ahead and take a look at the repo, and we can see in the examples there is one called Web Kiosk. And this is great. So build an image which automatically boots into kiosk mode to run an application on Wayland. That's exactly what we want to do. So let's take a look at how this works. There is a systemd service template here. This is going to start a binary called cage and pass this kiosk app as an argument. So let's go ahead and look here when we see the customize script. This is where, okay, we're going to do an apt install cage and chromium. Then we're going to configure the Chromium browser to, a couple of websites along with some arguments here for configuration kiosk, no error dialogues, disable info bars, right? This is all, I think, those commands that are locking down the browser when it is launched. And then we're going to pass that in. We're going to fill out this template and then also set this bdeb strap hook called enable units. This is important because this is going to help it run at the boot without having to log into the device. Okay, cool. So this is great, and we ought to be able to set up a project that just gets this running. There's a nice README here, and it just says, okay, build, pass in this generic 64 apt simple configuration and specify this as the external directory, and also pass in some options so that, let's see, if you need to be able to log into this system via the console, you need to specify a password and options file like this. Okay, so let's go ahead and see if we can get this running. Okay, so let's hop over to VS Code, and if you're familiar with my videos, we're gonna go ahead and create a very familiar structure here. We're gonna use a Docker file to build an image that we're gonna use to run rpi-image-gen. And then we're going to go ahead and create a Docker Compose file as well that we will use to mount a local directory. And also just, I am a very big fan of Docker Compose. It helps me keep things in order when I'm doing. Okay, great. And then what we're going to do is just go ahead and see if we can build the example that was provided and see if it works. So let's go ahead, Docker Compose build. Okay, excellent. And then Docker Compose run. And this is the RPI web kiosk. Okay, and we can see here rpi-image-gen, great. And let's just pass in what was suggested by Matthew. Here we go, build, passing this configuration and see if this works. Okay, great. Okay, excellent. And so next what we need to do is we have this image here in our work deploy directory. We're going to need to copy that out of here. So if we go ahead and then we can find the container ID and we can just copy from there. I'll just pull this image path and then we'll just copy that to our directory here. And then we're going to go ahead and take our USB stick here that we've been using. Again, I find the USB stick to be a little bit faster than the SD card, especially when you're iterating to get that gold master image. Speed is of the essence. So now we'll go ahead and use the RPI imager tool, and we're just going to specify we have the Pi 4 and come down here and we're going to find our image. Go ahead and open that and then select our media. Okay, great, and it is done. So let's go ahead and see what happens when we pop it into our Pi here. And again, this is the Pi 4. Got this little screen attached to it so that I can see what's happening. Okay, pop it in and plug it into the power. Go. And let's see what happens here. And I'll just show you here what is going on. We got our rainbow screen there. Okay. See some console output. Okay. Okay. And then, oh, there it goes. It's booting into kiosk mode. Okay. No internet. So if you're connected to the hardwire Ethernet, then this probably is not a problem for you. So if you have a kiosk and you're expecting to have hardwire Ethernet, then this isn't going to be an issue, and you can use this example. Really, what you're going to want to do is go ahead and specify which URL you want to boot up to. However, often that's not going to be the case, and one of the virtues of the Raspberry Pi is it does have Wi-Fi, and so it can connect to a wireless internet connection. And so the next step that we're going to take is we're going to go ahead and figure out how can we then configure the device when it's in this state, right, to connect to the internet. And remember, we don't want to have to set it up. We don't want to have to turn it on and do some administration. We would like it to just boot up and be usable by the customer. And so what we need to think about is how can we actually set up the wireless internet through this interface here. And so what comes to mind is whether we can set up a service that's running on the device that's going to be able to take an HTTP request and set the Wi-Fi that way. And so that's what we're going to do next. We're going to go ahead and see if we can't set up a service. We're going to write the service in Rust so that it's a simple binary, and we're not going to require any additional dependencies to run it. And then we're going to see if we can't set a simple SSID and password. Now, there are probably some more sophisticated wireless setups that would not be supported, but this should be a good head start on how you might go about setting up the device so that you can configure Wi-Fi, and at minimum it would let any of you that do have Wi-Fi that are running through this tutorial see how that would work. Remember, let's take a look at what we're dealing with here, right? So we're running Chromium with Cage. And what is Cage? So Cage, the Wayland Kiosk. Cage is a kiosk compositor for Wayland. A kiosk is a window manager in the X11 world, or a compositor in the Wayland world that is designed for a user experience wherein user interaction and activities outside the scope of the running application are prevented. So we talked about this. You want to really lock down the device both at the application and OS level so that people that are using it to order their burger or to check in to heaven cannot, compromise, do anything, cause a problem, even if it's not malicious, right? You don't want them clicking around and causing things, you want pop-ups showing. And so what is Wayland? Just real quick, Wayland is a replacement for the X11 Windows System protocol and architecture with the aim to be easier to develop, extend, and maintain. So X11 dates back, it's really a client-server type of protocol for managing a windowing system. And Wayland has been developed over the past decade or so to replace that. It's going to allow for more performance, especially with higher resolution screens and that sort of thing. And so we're going to need to work within these confines to set up and configure our Wi-Fi. And so what we can do then is let's hop back over to our code. And what we're going to try to do is follow a similar pattern that I used in a previous video where I asked AI to help me set up a Bluetooth service running on my Raspberry Pi. And I had asked it to help me write that in Rust. And if you recall from that video, Rust is a low-level language that allows us to compile a binary that will run on the Raspberry Pi without any additional dependencies. And so instead of installing Python or Ruby or the Java runtime, we can go ahead and just compile a binary, and using the S libraries that we have already, it's just going to run. So that's the pattern that we're going to follow for this tutorial. And what we're going to do is we're going to set up a Rust server that's going to let us configure the Wi-Fi via the browser. So we can set up the SSID and password and then write that to the system. And then hopefully we can then connect to the internet so that we can render out our Kiosk homepage. Okay, and again, this isn't necessary if you are going to run your Kiosk using a web app that's running on the local machine, right? So that's another model that you could pursue. The limits there we can talk about maybe in another video. I just want to get through this tutorial for you. But if you have questions about that, please ask, because that's another way that you could implement this, which wouldn't require network access at all. Okay, so let's go ahead and see here how we're going to do this. First, what we're going to do is, since we're going to be doing a little bit more, let's go ahead and create a directory here called Kiosk. And this is where we're going to create our external directory that we're going to reference when we run rpi-image-gen. Okay, and then we'll mount this into that container. And so we can go ahead and do that right now as well. We'll just add this volume to our container. That way, you know, what changes we make here on our host machine, when we then launch the container, they'll be present there and we can reference them and let rpi-image-gen utilize that as configuration. Okay, so the next thing that we're going to do here is we're going to go ahead and let's use an image layout that we're familiar with, that we've used before. So some of you may be familiar with this. So let's just go ahead and run through that process. Okay, so we've set up our basic structure, and this is really just a copy of what's at the top level of the project for the most part, with a few customizations, our options, the MacMind user. We're naming this profile MacMind RPI Web Kiosk. We're then referencing the profile here in the config file. We're also setting this boot partition and root partition to be slightly lower than the defaults in the project, and you'll see this manifest. You may recall here that we copied 4 gigs. This was based on the setting for the root part size in the default image, which is slightly bigger. So we're going to be able to reduce the size of our image. It means that there'll just be less overhead on the device, and this is something that you'll need to experiment a little bit with to figure out how much extra space do you need on the device. And then we have our command line and config.txt. This will play a role when we want to eliminate the output and show maybe a splash at the beginning instead of that console output. And then we have our image layout as well as our customization. So we'll start with our customizations, and this is where we're going to specify the packages that we want to install beyond that baseline. And it was a great question that came up in one of the previous videos. What's the difference between that default image and, let's say, the Raspberry Pi Lite image? And so I thought that was an interesting question. So I did do a diff of those two images. I took the SBOM output from rpi-image-gen for the default and the SBOM that I was able to locate for the Raspberry Pi Lite operating system. And it is significant, actually. There's a lot more in that Lite image than you get in the default image. So this is a very bare bones operating system that we are building here, and we're starting from there. So remember, I used that phrase whittling for the pattern that we see most following, where you install that base image from the Raspberry Pi distro, and then you whittle it away and you configure it, right? And you end up with something that works, but it's going to be a lot less optimized, right? It's going to be more than you need. And whereas here we're creating a mold that we're then going to cast the image from, right? And it's only going to be what we want to be present on that image. And that's why I am an advocate for this method, even though it may be slightly more complicated for some. Okay, so let's get back to it here. Customizations, and what we're going to include here in our image is a few packages that we're going to need. This looks something like this here. So we're going to install the firmware for the Wi-Fi radio on the device. This is important. Without this firmware, we have no Wi-Fi. Then we're going to install rf-kill. For those of you that saw one of my previous videos, we need to ensure that we enable Wi-Fi. By default, Linux is going to disable it with a utility called rf-kill. So we can go ahead and enable it with this utility. And then we're going to use WPA supplicant. This is a utility that I discovered, and this is not something that I'm super familiar with doing, setting up Wi-Fi, because most of the time you install the OS and it already has this stuff. Now we're starting from an even smaller foundation, right? So we're learning what exactly we need to get things moving. So we're going to install WPA supplicant as well as a DHCP client, so that we can configure our Wi-Fi and get an IP address. Okay, and then we have as well Cage and Chromium. And I'm going to install them here versus in the customized script. That way things are grouped together here, and I can really see this in a list form, and it doesn't feel as raw to me in this format, in a YAML format. Call that a personal preference. You could also install these packages from your script. And then curl, I installed this for some testing purposes as I was iterating to resolve some of the issues that I had seen that hopefully you won't see, because I've done this for you already and now making this video. So I don't think we need curl for this. A couple other things we'll set up. This looks familiar if you've seen some of these videos before, so we'll skip over that. Okay, great. So now we have our customizations. Now what we want to do is we want to add the logic to ensure that we are going to set up and boot to Chromium the way we did before. So that's going to look familiar, right? We're going to have a customized Kiosk script here. Okay, and that is going to do the following. So what we want to do now is we want to essentially take what Matthew had provided and just wholesale copy that over here, right? And instead of going and trying to connect now to an external service, we're just going to connect to a service running on our local host. And what we'll do is set up that service. Okay, great. So furthermore, I do want to also include a customized script that he has. I think it's customize 01. That does a few things here, installs E2FS progs and BTRFS progs. So I'm going to go ahead and include this. And actually, this is called customize 05 packages. Okay, great. Again, this is just from Matthew. I am not entirely sure what E2FS progs is or BTRFS progs, but I'm not going to stray from those. Oh, there's also one more here, DOSFS tools. Okay, great. So let's just include that and move on here. Okay. So now we have essentially what we had before, which is an image that just launches the browser. There's nothing going to be running on local host, so that's not too interesting. So what we want to do now is we want to build that service that's going to let us write out the Wi-Fi SSID and password. So let's go ahead then, and what we're going to do for that is we're going to create another project here in our RPI web kiosk, and we're just going to call this the Wi-Fi setup service. And similar to when we set up the Bluetooth service, this is just going to be a Rust application, right? And so Rust uses cargo to install dependencies, and we're also, so let's go ahead and set those up. These are the dependencies we're going to need for our Rust application: Actex, Web, and Saturday. Okay, great. And then we'll have a simple source code directory with one source code file called main.rs. Okay, great. And then we'll add our Docker file here. We'll call it dockerfile.wi-fi setup service. Okay, and this is just going to allow us to create a container with the dependencies that we need to actually compile the Rust code to the binary that we're going to need to copy over to our image. Okay, then we're going to let Docker Compose know about this. We'll call this the Wi-Fi setup service, and in similar fashion, we will reference the volume here that we had. We'll mount that into the container, reference our Docker file here. Okay, great. This should be what we need. Excellent. And then now what we want to do is write our service. And full disclosure, I did ask AI for some help with this again. I'm not a Rust programmer, but even if I was, or I'm becoming more comfortable with Rust, I still find it a little bit easier to get started with AI's direction. So I'll prompt AI, in this case it's Grok, hey, I want to write out the Wi-Fi SSID and password from a Rust service. How would I go about doing that? And it gets me started. That way I'm not staring at a blank canvas, right? Like writer's block or artist's block. I'm not sure what they call that when you're an artist staring at a blank canvas and you can't get started, but sometimes that happens. Let's go ahead and take a look at what that recommendation was. So here we have our code that was offered up by Grok, and we can see here that what is this doing? Again, I'm not a Rust developer necessarily by trade, although I am learning more and getting more and more comfortable with the syntax, but we can follow along here, and AI does a great job at explaining what's happening, often very wordy and verbose explanations, which is great. We see here we're going to use some of these crates, and these look somewhat familiar in terms of what we might be doing here. HTTP response, HTTP server, okay, web, and other terms that we are expecting to see. And then we're going to go ahead and create an index function here that looks like it's going to return some HTML. Okay, great. And we're familiar with HTML, or if you are, you can see here what we're doing. We're going to just create a form. And that form is going to take two fields, SSID and password, and then submit the form to via post, HTTP post to a set Wi-Fi endpoint. Okay, great. This looks pretty straightforward. And then here is that set Wi-Fi function. We would expect the form to be submitted here, and okay, great. What we're going to do now is set up the format for the wpa-supplicant.conf file. And you recall wpa-supplicant was the utility that we installed, and this is going to help us manage our Wi-Fi credentials, okay? So here we have the format of that file. Here is the location that we're going to want to write that to. Here is the interface that we are working with. and this is the code that we're going to run. So what's going to happen here, we're going to write out the file that we created here, right? And we have SSID and password that was submitted with the form, so those are going to get populated here. So at that point, we should have a comp file that has our credentials that were submitted through that browser interface. And then we'll go ahead and kill the WPA supplicant application and restart it here, right? So we're going to pass some config arguments and the interface that we specified, which is the wireless LAN. And then we're going to use this configuration that we just wrote out. Okay, that looks like what's happening there. And then we'll see if that works. We'll go ahead and get an IP, and we're going to use DH client for that. You recall that we did install DH client right here. This is the DHCP client that we installed. Okay, great. So we ought to be able to use that. And if that is successful, we should redirect to an environment variable that we specify called kiosk homepage URL, or we'll go ahead and fall back to this URL that I've specified here. And this is a cool little sample app that I found that is fun to see it working. Okay, great. Coming down through here, if things error out, we'll get and return these errors. Okay, great. And then we'll go ahead and start this web server. Easy peasy. So this now is our Rust web service. And if we've done things correctly, we ought to be able to compile that, and then we'll copy it into our image layout. And then when we build our image, it will be available to the device to run. So what we'll do is set that up so that it runs when the device boots. Okay, great. So let's come back over here and we'll go ahead and keep this running container for now. I'm gonna next go ahead and see that we can build the service that we just set up called Wi-Fi setup service. Okay, and we can, great. And now let's see if we can run that. And we'll just shell in there, excuse me, dash dash. Okay, great. And then the command that we need to compile our application is going to look something like this. Cargo build, we're going to compile a release binary, and we're going to specify the architecture to be 64-bit ARM architecture. Okay, great. And let's see if that works. Okay, excellent. Now it's just installing the dependencies. This may seem like more than we put in our cargo.lock, but that's because it's installing dependencies of dependencies that you may have seen this as a familiar type outcome when you're building applications in other languages. It's compiling. Okay, excellent. That is now compiled, and if we look here, again, because we mounted this volume, we're going to see what happened there on our host machine, right? Even though this is happening in the container. So we have now our target, and we have our release, and there's our binary right there. Okay, excellent. So what we want to do is we want to make sure that binary is going to be available when the device boots, right? And so the easiest way to do this is to just create a rootfs overlay that rpi-image-gen will then rsync to the image layout when it is running. So let's go ahead and do that. So this will be called device, and then it's going to be root fs overlay. And then we're just going to put this in user local bin. Okay, excellent. And then we will go ahead and let's just move this here, and easy peasy. Okay, cool. So now our binary is there in user local bin. Okay, excellent. So what's next then? What we want to do is we want to run this when the device boots. Okay, so how do we do that? We can update our customized kiosk script to do that. And the way that we're going to do that is let's go ahead and create a kiosk directory here. And this is now going to include something we'll call Wi-Fi setup service, okay? And actually we'll get a little bit more specific and call this kiosk conf. Okay, great. And then this is going to be Wi-Fi setup.service. Excellent. And this is what that's going to look like. We're going to create a systemd service config here, and this is the Wi-Fi service for setting up Wi-Fi SSD and password via the browser. Great. The binary is here, and we're just going to run that when the device starts up. Okay, great. So now we need to make sure that this is available to the device, and we'll do that by using rsync. Okay, great. And we can now just rsync this here. Okay, excellent. And let's go ahead and set up this bash script with some boilerplate. Okay, excellent. Now we have our systemd service. Recall I said that Wi-Fi is commonly disabled by default, and to ensure that it is enabled, let's go ahead and create another service that's going to ensure that it is enabled, and we'll call this unblock Wi-Fi service. Okay, and so this will come in here, and we'll just call this unblock Wi-Fi service. Excellent. And it's again a systemd service, and we'll go ahead and say, okay, start this RF kill unblock Wi-Fi when the device is booting up. Okay, great. Then similarly, we'll just rsync that over so that we ensure it runs, it's there in the image. Okay, excellent. There we go. So write out our systemd service to unblock Wi-Fi. Okay, great. With those changes, the last thing I want to make sure that we're doing is, if you recall here, we are setting things up, and when we are going to write out our WPA supplicant conf, when that's the password, excuse me, the SSID and password are submitted to our Rust server, we write out to this conf file. I do want to make sure that this directory exists. So the way that we do that is we're just going to go ahead and create that directory here in our customized script. Okay, excellent. And then we need to make sure that we have our kiosk service template as well. So let's go ahead and create that. We have our kiosk service. Yeah. And this is going to look something like this. And this has some variables that will be filled in, right, in our customized script, right? This is where we're going to use sed to fill in the variables in that template and write out our kiosk service. And then we're going to enable that kiosk. Okay, one more thing we need to also do is we need to enable Wi-Fi setup at the start. Okay, excellent. So I think we have everything we need here now. We have our unblock Wi-Fi service. We've created our WPA supplicant directory, and we have our Wi-Fi setup service, and we've specified our startup command for cage, and we have our kiosk service that we're writing out, populating with these variables. Okay, great. So we ought to be able to build this image now and see what happens. Okay, and it looks like that's done. So again, we're going to come in here and let's go ahead and check container ID and copy, and similar as before, we'll just take this path and copy it here to our, we should see that pop up. There it is. Okay, and you can see it's 1.75 gigs versus the 4 gigs that we saw before, and that has to do with that root part configuration that I mentioned earlier, where we are specifying a smaller root part size than the default. Okay, great. So now we have our image. Let's go ahead and see if we can install it on our trusty thumbnail drive and see if this goes and what happens. Again, we have our thumbnail drive there. Okay. Okay, great. So that's done. And now we'll go ahead and see if we pop it into our device. Okay, and power it up. All right, and we'll try and show you guys what's happening here. So, see okay, and it's booting. Excellent. Again, some console there. We can clean that up and show a splash image if we want to. Okay, great. So now we see set Wi-Fi, right? Okay, excellent. So let's go ahead and do that. Okay. And then when I click connect here, we'll go ahead, submit that. Now what it's going to be doing is should be setting the Wi-Fi credentials and then trying to obtain an IP address, and sure enough. Okay, cool. And now we have our kiosk here. All right, this is OB Real Hot Fast Food. Pretty cool, huh? And we can see here, right, how cool is this? And this is a fun little app. I don't understand this language on here, but you can see the pictures, right? You know, you want to play cash or card there. Okay, we're card people. And now it's loading up my menu. Right, there we have our menu. Pretty cool, huh? So we have our kiosk. It's connected to our network via Wi-Fi. We were able to set those credentials without leaving this caged Wayland kiosk environment. And so that's going to be a nice way that you can potentially configure your device so that you have a gold master image that just the device will boot into this state. Okay, then the last thing that we want to think about is that console output at the beginning. And for that, what you can do is just refer back to the previous video that we made on with the splash screen. And when we look at that, we see that we were using Plymouth to set up a splash screen. And that was here in our image. And we followed a similar pattern so that we set up the Plymouth themes, and we had both the blockchain animation as well as the MacMind animation, right? So here we were specifying that we wanted the theme to be the blockchain animation, and then including that here with our Plymouth themes, right? Blockchain. So if we add that here to our kiosk, then we would go ahead and see that splash screen instead of that console output at the beginning. So that's it for this video. Thanks for tuning in today to learn about building a custom Raspberry Pi image that boots in kiosk mode and setting up networking. If you liked it, please make sure to tap that thumbs up icon. It really helps me out and gives others a chance to see this content. Let me know your thoughts in the comments section. Does this work for you? Is there more you'd like to see on this kiosk topic or other topics you're interested in? I'd love to hear about it. And again, if you haven't, please consider subscribing to this channel. There are more videos coming on how to build custom Raspberry Pi images so you get the most out of your Raspberry Pi hardware. And I also have plans to make more videos on blockchain and AI topics. I hope you're having a great day, and remember, don't stop experimenting, challenging assumptions, and seeking the objective truth. I'm Johnny Mac. This is MacMind.io.